Hello and welcome to this section. Now we will start talking about special methods in Python. They are also called magic methods, and you will see why in just a moment. The first thing that you will notice about these methods is that their names start and end with double underscores. This is key, double underscores. Here we have the basic structure of the name of a special method in Python. We have double leading underscores, followed by the name of the method, and then double trailing underscores. Right here within parentheses, we will have the necessary parameters. Of course, self will be the first parameter, and then we can add the parameters that we need for that specific method. You will learn how to do this during this section. Here we have some examples. We have the method add, the method string. This is an abbreviation of representation, REPR. You will see why these two methods are similar and yet they perform different functionality. We will also cover the length method, bool, EQ, LT. These are part of what we call rich comparison methods. We will see these and other methods that we can implement in our classes to be able to compare objects. And right here we have another example of a method, sizeOf. This is another special method. I'm sure that you immediately noticed visually that all of these names are surrounded by double leading and trailing underscores. This type of method is also called dunder methods. Why? Because they have double underscores. Double underscores. And why are they called magic? Well, because they add special functionality to the class and to the objects that we will create from the class. But they act behind the scenes. They act indirectly. They are meant to be called indirectly through other methods or actions. We're not going to call them like we usually do, writing the name of the method and passing the arguments. We're going to call them indirectly through other methods or actions. For example, in Python, I'm sure that you've done this like a million times. We add two numbers, like for example 5 and 6, using the plus operator. But actually, behind the scenes, we are calling the add method of the integer class to perform this operation. We're not actually calling this method. We're not writing add with double leading and trailing underscores and then passing the arguments. We are just writing this operation using the plus operator, and behind the scenes, this method is being called. You will see that this is true in just a moment with a practical example. With this concise syntax, we're basically doing something that is equivalent to this behind the scenes. We're taking the first number, and we are calling the add method on that first number, passing the second number as the argument. That will call the add method, and the result will be the sum of these two integers. But this is all done behind the scenes, for us automatically when we use the plus operator. And that is basically the principle of magic methods. We perform other operations, and they are being called behind the scenes. Let's see how this particular example works in our code. Right here, I'm in my PyCharm project, Python OOP, as you can see right here, and we have a main file, which we are going to run with our examples. Let's see that this is actually happening behind the scenes. Let's print the result of adding 5 and 6. We know that the result will be 11. Let's run the code, and we see the output, 11. Let me zoom in so we can see this a little bit better. And what do you think will happen if we call this instead of using the plus operator? We write this, the number surrounded with parentheses, then we call the method add with double leading and trailing underscores, and we pass within parentheses the number 6 as argument. This, believe it or not, is equivalent to this. We're just using a more concise syntax because magic methods are not meant to be called directly. Let's save the file and run our code. And we see that the output is exactly the same, 11. We are adding 5 and 6 using a different syntax. This is what actually happens behind the scenes when we write the plus operator. Now let's see if this works if we assign the result of 5 plus 6 to a variable. Result 5 plus 6, and we print the result right here. We know that with the plus operator this will work. We have 11, so nothing has changed so far. And surprisingly, we can also assign the result of this method call, the value returned, to a variable. We can use the same variable result. This is equivalent to this. It will return the value and we can assign that value to the variable result. If we save the file and we run the code, we see the same output, 11 and 11. Quite surprising, right? When we write this, we actually call this. We're actually doing this behind the scenes. This was just one example of a special or magic method in Python. There are many more that you can implement, and you will learn more about them, how to use them, and how to implement them in this section. So I'll see you in the next video. Let's see what the Python documentation can tell us about special methods in Python, what they are used for, and how we can define them. To learn more about these methods, we have to go to the data model article in the documentation. Once we reach that article, we just click right here, section 3.3, special method names. And we reach that part of the article that covers special methods. We also have some details about each one of the special methods that we can define in our class. For now, let's focus on this part right here, which is a basic introduction to this type of method. And let's see how we can reach this article. You go to Google and you just type Python docs data model, okay? You click enter and the first search result will very likely be this one right here with the latest version of the documentation. Wherever you see docs.python.org, that will be an article of the official documentation. We click on it and we reach this article, which is exactly what we need. Once we reach the article, we go to section 3.3, special method names. And let's read its content. A class can implement certain operations that are invoked by a special syntax, such as arithmetic operations or subscripting and slicing, by defining methods with special names. This is Python's approach to operator overloading, allowing classes to define their own behavior with respect to language operators. Operator overloading is just basically customizing what happens when we use a specific operator of the language with a specific data type. For example, with the plus operator, we can concatenate strings, we can add integers, and we can also concatenate lists, but the behavior of the operator is different for each data type that we work with. That is basically how operator overloading works behind the scenes. You can provide different functionality for different data types with the same operator. Right here we have an example of a magic method that we can implement. We will see more about this special method in this section. We will see some practical examples as well. Let's see. For instance, if a class defines a method named getitem, and X is an instance of this class, then we can index that instance. Just like we index, for example, strings or lists, we will be able to use this syntax to index the instance. And that will be roughly equivalent to this right here. So they're acting behind the scenes and they're providing special functionality. Right here we can see some information about exceptions. Except where mentioned, attempts to execute an operation raise an exception when no appropriate method is defined, typically attribute error or type error. Right here we also see that setting a special method to none indicates that the corresponding operation is not available. For the last paragraph, we see a suggestion. When implementing a class that emulates a built-in type, it is important that the emulation only be implemented to the degree that it makes sense for the object that is being modeled. For example, some sequences may work well with retrieval of individual elements, but extracting a slice may not make sense. This is basically telling us that we should only implement the methods that really make sense for the object that we are modeling. Some objects may logically allow indexing, some objects may not. Some objects can be added to get a final result and some may not. So you should only implement the special methods that make sense for that object. Awesome! Now you know how to learn more about these methods in the documentation. Right here we have more details about each one of them, and we will see them in detail when we cover them during this section. Great, so when you're ready, let's start diving into our first special method. Now let's talk about the special method str, which is an abbreviation of string. Why and when should we use this method? When should we implement it in our class and why? Let's see what we can find in the documentation. If we go to the data model article in the documentation where we said that we could find all the information for the magic methods in Python, we can click right here in section 3.3, special method names, and we can go to basic customization. Right here you will find all the information for the method. Let's just search right here to find the method, and right here we can see it, str. Let's see what we can learn from this description. There are 3 indirect ways of calling this method. It is called when we call str on an object, so we want to convert it or cast it to a string, like we do right here. And it's also called when we call the built-in functions format and print to compute the informal or nicely printable string representation of an object. The return value must be a string object. So if we try to print something, like for example when we print a list or a string or a number, this method is called behind the scenes. So based on what you just read in the documentation, when we call the print function on an object or the format function, we are calling the str method indirectly. We're calling the special method indirectly, and the value that we see printed as the output is the value returned by this method. Okay? So if you want to customize how an object looks when you print it using the print function, you have to implement the str method in your class. Great, so let's start diving into a practical example. First, think about how you would implement this method in a class that represents a 2-dimensional point, a point with an x-coordinate and a y-coordinate. How would you print it? Pause the video for a moment, think about it, and then come back so we can start writing the code. Let's start writing the point2d class. We're going to write this class in the main file of the Python OP project. First, we write class and then we write the name of the class, point2d, okay? A point in a 2-dimensional plane with x and y coordinate. First of all, we have to define the class constructor, init. You can see the PyCharm already completes the first parameter, which is self. And we want to take x and y as arguments to create an instance. We assign these 2 values as instance attributes, x and y. For now, we're going to make these attributes public because this will be a simple class. Okay, so after that, what do we want to do? We want to customize how our point, our 2-dimensional point, will be displayed when we print an instance of the class. So we have to define the str special method. In this case, str doesn't take any arguments. It doesn't have any other parameters besides self. And in the body of the method, we have to return a string. Remember that the documentation said that we have to return a string from this method. And that string will be used to describe the object when we try to print it. We're going to use an f string. F strings were introduced in Python 3.6, so you can use them in Python 3.6 or later versions. And how are we going to do that? Well, we are going to present the point as a tuple. The usual mathematical notation for a 2D point is the x-coordinate, like this, followed by the y-coordinate, separated by a comma and a space, surrounded with parentheses. So that is the representation that we are going to print for the point instance. We're going to print its coordinates. You can see that we're going to customize it, but first we have to add self, because these values will be customized for each instance. So the output will be helpful. It will provide more information about the point instance that we are working with or that we are printing. Let's see how this works. Let's save the file, and now we're going to define an instance. Let's call it myPoint. Point2d. We use the class that we just defined, and within parentheses, we need to pass the x and the y coordinates as arguments. Let's say, for example, 56 and 60. After we have that instance defined, we just need to print it to see how the str method works behind the scenes. If we try to print the point right now, we save the file, We add a blank line right here to follow the best practices of the Python style guide. We run the file, and we see this as the output. When we print the instance myPoint, we are getting this as the output. We are getting its x-coordinate, which we defined right here, and its y-coordinate, which we defined right here when we created the instance. Notice what happens if we don't define this method. Let's say that we delete this method. And we just have this line that creates the instance, and we print it. Let's run the code. We see the data type of the object, we see that it is a two-dimensional point2D, an instance of this class, and is located at this particular address in memory. So this is the default implementation when you try to print an object that doesn't have the str method implemented. But if we reverse these changes, now we run the code and we see the data that we wanted to display, the x and the y coordinates of the point. Great, so this was our first example of how the str method works behind the scenes. Let's go to another example where we will implement a student class to print the data of each student when we try to print an instance. Okay, so let's start writing our student class. This is another example of how you can customize the output when you print an instance of the class if you customize or implement the str magic method. We define the student class, and now we need the constructor, init with self. We're going to take as arguments the student ID, the name, the age, and the GPA. We assign them as instance attributes. Self.studentID, self.name, name, self.age, age, and self.gpa, GPA, okay? Now we have our class constructor. We will need to pass these arguments when we create a student instance, and we assign them as instance attributes. Now let's customize or implement the str method, so we can avoid using the default implementation. Let's say that we want to be more descriptive about the student. When we print a student, we want to know its 4 main attributes, these ones right here. So let's return a string with this data. We're going to write an f string, and we say student, and let's print the name first to make the output more friendly instead of the ID. But this is totally up to you. You can customize it to your liking. We can also print the ID after the name, the age, self.age, and the GPA, like this, self.gpa. Since this string is quite a long string and it has more characters that we can show on the screen at once, it would be more comfortable and recommended for readability purposes to break this string into multiple lines. So let's see how we can do that. We just end the string with, part of the string with a double quote, we add a backslash, and then we click enter. We start another f string on the next line, and we do exactly the same. We just write this, a backslash at the end of the line, and we start each part of the string with an f to make it an f string. So now we have our string and our representation of a student instance. When we call print on a student instance, this data will be presented. Let's check this. Let's create a student instance from the student class, and let's assign, for example, the student ID 42AB9. The name will be Nora Nav. She will be 34 years old and her GPA is 3.76. Now if we call print on that instance, we will see this data. Let's save the file and run our code. We add one line right here, we run our code, and we see this as the output. Awesome, right? We see the data of the student printed on the same line because we are using this right here to indicate that we want to continue the same line, and we see the values of the instance replaced. We see the name, we see the student ID, the age, and the GPA. Notice that right here we are not having a space after this last value right here. That can be solved quite easily by just adding a space at the end of each string right here. So if we run the code again, we see that the spaces were added successfully. The important thing is that we were able to customize how the instance is printed and the data that is displayed. We are not using the default implementation. Awesome, so now you know how to customize what is printed when you print your instance. When you're ready, go to the next video, where you will learn more about the next special method that you can customize and implement in Python. Now let's talk about the special method length, how we can implement it, and when we should use it. Let's see what we can learn from the Python documentation. Now we're back to the article Data Model, and again we have to click on section 3.3, Special Method Names. After that we have to search for the subsection 3.3.7 in this case. It's almost at the end of the article in the documentation. 3.3.7 right here. Emulating container types. That's what we are going to do. By implementing the length function, we are going to emulate a container type, like a list, like a tuple, like a dictionary. They all have length, and strings have a length as well. Right here we can see the description of this method, object.length, and we have self as the only parameter. Let's see what the documentation says about this special method. It says that this special method is called to implement the built-in function, length. Right here, the built-in function that we typically use to get the length of a sequence. That method should return the length of the object, an integer that has to be greater than or equal to 0. You cannot return a float from this method. If you try to return a float, you will get an error. Right here, we also have another case that mentions the bool special method, but we will get to that once we reach the video that covers this special method in more detail. So, based on what we just read in the documentation, whenever we call the length function to get the length of a sequence, or in this case of an object of a class that we defined in our program, we are actually calling the length method, the special method length, indirectly. And the value that we get from calling the length function is the value returned by the special method. Right here, we are back to PyCharm. We have the Python OP project and the main file. And right here, we're going to write our examples to prove that calling the length function is equivalent to calling the length method. It just happens behind the scenes. First, let's start by defining a string. We say my string, and we are going to assign hello world as the string for this variable. After that, we are going to print the length of my string using the length function. And how are we going to check that this is equal to the method? Well, we write the name of the variable, the string, and strings have a length method, a special method that is called behind the scenes, but we can call it explicitly. If we call it explicitly and we use empty parentheses right here, because this method doesn't take any arguments, we will get the length of the string as well. Let's save the file and run the code. And right here we see that the numbers are equal. 13 is the length returned by the function and returned by the method. The number is exactly the same. This is true for a string, but now let's see what happens if we have a list. 1, 2, 3, 4, and 5. And we also print the result of calling the length method on the list. We comment this out temporarily so we don't run these lines of code. We run the code and we see the number 5 because we only have 5 elements in this list. So you can see that we're starting to confirm that calling length as a function and as a method, as a special method, is equivalent. Now let's comment this out and let's try this with a tuple. But first, let me copy and paste this right here. You have to be very careful when you copy and paste. But this will just be a small change, replacing the square brackets with parentheses and changing the name of the variable. My tuple, we have my tuple right here and we have my tuple right here. So we know that there are no possible bugs. We made all the necessary changes. We save the file, we run the code, and right here we see 5 as the output, because the tuple had 5 elements, and that is the correct length. Finally, we tested this with strings, lists, and tuples, so we can also try this with a dictionary. Right here, we define the variable myDict, and we map keys to the corresponding values. We associate them, A to 1, B to 2, and C to 3 in this case. This is just a basic sample dictionary. We will use the same function calls, print and length, and we will also call the length method on the dictionary, right here. If we save the file and we run the code, we see that the length of the dictionary is 3 because we have 3 key value pairs, and that is correct, and both results are equal when we call the function and when we call the special method. So this is all happening behind the scenes. We just use a more concise syntax, and we can customize what happens right here when we call the function if we implement this method in our class. Awesome! We've confirmed that this is equivalent for built-in data types and data structures. Now we will start coding our second example. But first, think about how you would implement this method in a backpack class. If we want to get how many items are in the backpack. Pause the video for a moment, think about this, and then come back. Remember, a backpack and the length should be how many items are in the backpack at any given moment, when we call the length function. Let's write our backpack class. Right here, I'm working on the main file of my Python OOP project in PyCharm. First of all, we have to write the class header. We write the class keyword and we write the name of the class, backpack. Initially, when we create a backpack, it will be empty. So what are we going to do? We are going to define init. And in init, we are not going to add any parameters to this list. We're not going to take any arguments when we create an instance. We are just going to have an empty list of items because the backpack will be initially empty. After we have that, we have to define 2 methods. A method to add an item to the backpack and a method to remove an item. We're going to simulate this. So the method will be called addItem. In this case, we do have to add a second parameter because we have to specify what item we want to add to the backpack. And what are we going to do once we have that item? Well, we are going to append the item to the list of items in the backpack. This is the list of items when we use self.items. This attribute that we have right here for the backpack instance. We append the item. For simplicity purposes, in this example, we are going to describe the item with a string, but this could also be a custom object that you define. Okay, so we have our addItem method. Let's start defining our removeItem method. And in this case, we will also need a second parameter, the item that we want to remove. In this method, we will have to check something before we actually remove the item. We have to check if the item is in the list of items first. If that is the case, then we can remove the item and we will not get any errors. So it's best to check this before trying to remove the item. We call the remove method on the list of items in the backpack, and we remove the item only if the item is in the list of items. Else, if the item is not in the list, then we can just, for example, print a message and say this item is not in the backpack, like this. Awesome. Now we have our 2 methods, addItem, removeItem, and we also have our constructor. So let's start defining our special method. In the context of a backpack, we are going to define the length of a backpack as the number of items it contains. So it will be the length of this list that we have right here. It's initially empty, so initially the length of the backpack will be 0. But as we add items to the backpack, the length will be incremented. And it will always be an integer. So this meets all the criteria that we needed. We just write return, and what are we going to return? The length of the list of items. Okay? Notice that right here we are using the built-in function within the special method. But we are using that function to get the number of items in the backpack, the length of the list, self.items. Awesome, so now we have our class. Let's start defining an instance. We will call it myBackpack. And let's create the instance with the backpack class, as you can see right here. Let me zoom out so we can see the name. backpack right here. And since we don't have any arguments that we need to pass to create the instance, we just write empty parentheses. After we have that instance, we just have to start adding items. And how do we do that? We use the instance and we call the method addItem on that instance. As you can see right here, we have an item that we need to specify to call the method. So let's say that, for example, we're going camping and we are going to include a water bottle in the backpack. We also want to add a first aid kit in case anything happens, and we also want to add a sleeping bag. That will be very helpful if we want to spend the night in the mountain. Great, so now we have our backpack with 3 items. Let me just add another line right here. And what are we going to do now? We have 3 items. So based on what we defined as the length of a backpack, the length should be 3. How many items we have in the backpack? Let's check that this is true. We're going to print the length of the my backpack instance, okay? So let's save the file and run the code to see if we get the output that we expected. Right here we see 3 as the output. That is the length of the backpack. That is correct because we added 3 items to this backpack instance. And that is awesome. We can define the length according to our context. In this case, in a backpack, we have the number of items defined as the length. Let's also test how the removeItem method works. We call the method on the myBackpack instance, and we are going to remove the sleeping bag. Because let's say that in the last moment, we decided that we are not going to spend the night in the mountain. We are removing that item from the backpack, and once we remove the item, the length should be updated. Previously, we had 3 items, and now we have 2 items. So let's print the length again after removing the item, and let's see what we get. The length was updated correctly. Previously, we had 3 items that we added with the addItem method. And now we have 2 items because we removed an item from the backpack. Awesome. So let's see what happens if we just remove the other items that we had added to the backpack. For example, we remove the water bottle and we remove the first aid kit. Now let's print the length of the backpack, my backpack. Let's save the file and run the code. And now we see exactly what we expected, so the method is working correctly. We had 3 items, then after we remove an item, we have 2 items, and after we remove the other items left, we have 0 items left in the backpack. The backpack is empty. Now, if we try to remove an item, let's say, for example, water bottle again, the backpack should be empty. So we should get a message like this. Let's run the code and we see exactly that. This item is not in the backpack. Awesome, so now you know how to customize the length of your instances using the special method length. In the context of a backpack, we defined it as the number of items. But you can define what length means for your custom objects. And it's important to only implement this if it really makes sense for an object to have a length. Awesome! When you're ready, go to the next video to continue learning more about these special methods. Now let's talk about the special method add, how we can implement it, and when and how we should use it. Let's see what we can learn from this method in the Python documentation. If we go to the data model article in the documentation, to find the add method, we will have to go to this section right here, emulating numeric types. We click on it and we are taken directly to the part of the article where we can find the add special method. Let's see what this says about emulating numeric types. The following methods can be defined to emulate numeric objects. Methods corresponding to operations that are not supported by the particular kind of number implemented should be left undefined. Right here we can see that this method takes 2 parameters, self and other, the 2 operands that will be involved in the operation. Let's see what it says right here. These methods are called to implement the binary arithmetic operations. You can see all the operations right here. with the corresponding symbols, because all of these special methods can be customized and they correspond to binary arithmetic operations. For instance, to evaluate the expression x plus y, where x is an instance of a class that has an add method defined, then this is what is actually being called behind the scenes, okay? This is what happens behind the scenes when we use the plus operator. The add method is called behind the scenes. This is the part that we're interested in right now, how we are going to customize the behavior of the plus operator by customizing and implementing the add method in our class. So, based on what we just read, when we add two objects using the plus operator, we're actually calling the add method the special method indirectly. Awesome, right? They act behind the scenes. If we implement this method in our custom class, in the class that we write in our code, we can actually define what happens when we write something like this, when we try to add two instances of the class. We will see this in just a moment, but first let's see how this operator works with objects of built-in data types, such as integers, strings, and lists. This will be a really nice example of operator overloading, how the behavior of this operator in the language can be customized for each specific type of element or object that we are working with. Let's start coding. Right here, I am in my Python project, Python OOP, in my main file. Let's see how the plus operator is an example of operator overloading, because the behavior of the operator is different depending on the data type that we are operating with. First, let's see the effect of adding two integers. We know that they will be added, but let's confirm that we are actually calling the special method add behind the scenes. We write the first number, 3 in this case, and that number has an add method, because the integer class has an add method defined. If we add 3 to the number 4, we pass 4 as the argument, we will see the output. Let's save the file and run the code. First, let's zoom in. We run the code, and right here we see the value 7. So they are both equivalent, 3 plus 4, and calling the special method add. This is being called behind the scenes when we use this operator in Python. This is an example with integers. So let's see how this works with strings. For example, let's say that we want to concatenate two strings. For that, we would use the plus operator too. Notice how the behavior of the operator is different based on the data type that we are working with. If we add two integers, then the result is another integer. If we add two strings, the result is another string with all the characters in both strings. That is an example of operator overloading, and that is exactly what you can achieve by customizing the add method in your class. In this case, let's check that the result of concatenating these two strings with the plus operator is equivalent to calling the add method on the string. We call the add method on the first string and we concatenate or we add the second string. Right here, we pass it as the argument. First, let's comment out these two lines so we only see the output related to strings. Let's save the file, we run the code, and right here we see the same output. We see a single string made with the characters of both strings, so they are concatenated. They are equivalent using this operator or calling the add method, but in Python we use this operator, and this is called behind the scenes. This works with strings as well. So now let's test how it works with sequences, like for example lists. If we have two lists, we will be concatenating the lists. We will be joining those lists. And we will be making a single list with all of the elements in both lists when we use this operator. Notice that the behavior is customized. When we add two integers, we get an integer. When we add two strings, we get a string. When we add two lists, we get a list. And that is exactly the behavior that we have to implement in our add method when we customize it in our next example. We usually return an object of the same data type as the arguments. Okay, so let's confirm that this is equivalent to calling the add method. We're going to call this on the list, call the add method on the list, and we are going to add the list 4, 5, 6 with the elements 4, 5, 6. Right here. We save the file and we run the code, and right here we see the output. We get a single list with all of the elements that were in the two individual lists that we wanted to concatenate or join. Awesome, now you know that this works for built-in data types, and you're going to learn how to customize it for the objects of your class. Now we've completed our first example. Think about how you would add 2 points with x and y coordinates. How would you implement the special method add in this class in point2D? I'll give you a hint. When we add 2 points, we add the corresponding coordinates, the x-coordinate with the x-coordinate and the y-coordinate with the y-coordinate respectively. And the result is another point with 2 coordinates. Think about this for a moment and then come back so we can start working on the code. Right here we are in PyCharm and we are going to start implementing our point2D class with a new special method, the add method. So we will be able to add 2 or more points with 2 coordinates, x and y. Let's start with the class header. We say point2D. That will be the name of the class. We can't start the name with a number, so that is why instead of 2D point, we write point2D. After that, we need the constructor, init. And what do we need to know to be able to create a point instance? Well, we need to know the x and the y coordinates of the instance. We assign them as instance attributes. And since our class will be very simple, I'm going to make these attributes public. Okay? After we define the constructor, we can create point instances. But what do we need to implement in this case? We have to implement the special method add. So we can customize or determine what happens if we add 2 instances of the class. You can see that by default, PyCharm added a second parameter right here to the list. This parameter is named other. Why? Because we need to know what element we are going to add. Remember that in our previous examples, we added 2 integers using the add method explicitly. What did we do right here? We took the first element, we called the method on that element, on that value, the integer, and then right here we were passing a second value as the argument to the method. That argument, that second value that we are going to operate on, the second operand, the operand to the right, will be the value of other, whenever we use the plus operator. Okay? So, what are we going to do with that? We can take the data from the current instance using self, and we can also combine it or work with the data of the other element. We have the 2 values. We have references to the 2 objects, the object to the left and the object to the right. So for example, if we write this, object 1 plus object 2, object 1 will be assigned to self and object 2 will be assigned to other. So we can work with their individual attributes. That is awesome because we will need to use them to get a new point instance. When we add 2 points, we add the respective coordinates. The x-coordinate, like this, and the y-coordinate to get the new x and y coordinate of the point. We take the x-coordinate of self, the left operand, and the x-coordinate of the right operand, and we use them to get a new value for x. That will be the x-coordinate of the new point. And then we take the y-coordinate of the left operand and we add it to the y-coordinate of the right operand. And that way we will have a new y-coordinate. And what are we going to do with that? Well, remember that when we added 2 strings, the result was a string. When we added 2 lists, the result was a list. So when we add 2 points, the result will be a point. So we have to return a new point instance. We are going to create that instance right here and we are going to return it. But for us to create an instance, we have to specify the value of x and y. And what are those values? Well, new x and new y, the new coordinates that we calculated by adding the x coordinates and the y coordinates. And that will return the new point instance. That is basically how you need to implement this method in a point class. Awesome, right? Now, instead of just returning a value like a string or an integer, we are actually creating an instance of the class with its corresponding attributes, initial attributes. and we're going to return that instance so we can use it in our program when we add two instances. Finally, to complete the implementation of this class, let's implement the special method string, str. We're going to print its x-coordinate and its y-coordinate, like in mathematics. Okay, so now we have our class. Let's start testing it with some instances. Point A will be a point 2D with coordinates 5 and 6. And point B will be point 2D with coordinates 2 and 3. Okay, we have the instances right here. And what are we going to do with those instances? We are going to add them so we can get a third point. Point A plus point B will give us a new point instance, point C. We create the instances, then we add the instances, and from that addition, we will get a new point instance, point C. That new instance will have as its initial coordinates 5 plus 2, the sum of the x-coordinates, and 6 plus 3 as the y-coordinate. Let's print the value so we can see that it's actually working as we expected. Let's print the values of point A and point B, their coordinates. Let's print their coordinates. We're going to print each one of the instances and point C, so you can see that the result is the addition of the coordinates. Right here you can see it. Point A has coordinates 5 and 6. Point B has coordinates 2 and 3, like we have right here. 5 and 6, 2 and 3, and when we add them, we get a new point instance. And that point has as the x-coordinate the value 7, 5 plus 2, and the value 9 as the y-coordinate, 6 plus 3. So it is a point instance and it has the correct attributes that we expected from the class. Awesome! Now you know how to implement the add method. Remember, we take self, which is the left operand, and we add it to another instance, the right operand. We can use the data from both operands to get the sum of the instances, and we return a new instance of the class with its corresponding attributes. That is basically how you can implement this method. When you're ready, go to the next video so you can learn more about special methods in Python and how you can add them to your classes. Now let's talk about a really cool special method that we can implement in our classes, getitem. When we implement this method, we can actually index an object, just like we index a string, a list, or a tuple, but we will be customizing how the object is indexed. Let's see what we can learn about this method in the documentation. If we go to the data model article in the documentation, and we click right here on table of contents, we go to section 3.3.7 where it says emulating container types. We click on it, we will go directly to the part of the article where we can find that method. We just have to scroll down a little bit and we will reach the method almost immediately. Let's see what the documentation has to say about this method. We see that it has two parameters, self and key. Why? Because we need to know the key that we are going to use to index the object. So we have to include these two parameters when we define this method in our class. Let's read the description. This method is called to implement the evaluation of self and key when we use the key to index the instance. For sequence types, the accepted keys should be integers and slice objects. Note that the special interpretation of negative indices if the class wishes to emulate a sequence type is up to the getitem method. So we can actually implement indexing and slicing. So according to what we just read in the documentation, when we index an object like this, we are actually calling the getitem method indirectly behind the scenes. Let's see how this works behind the scenes for the built-in data structures that you have worked with since you started learning Python. Right here, we're back to PyCharm, and now let's confirm that when we index a sequence in Python, we are actually calling the getitem method behind the scenes. We're going to start by defining a list, and that list will contain 4 strings, A, B, C, and D, okay? What are we going to do? We're going to get the individual elements one at a time through list indexing. We're going to use their corresponding indices. Okay? 0, 1, 2, and 3. And what are we going to do now? We're going to prove that this output is the same output that we get if we call the getitem method on the list. We do this right here, getitem, and what do we have to specify? Within parentheses, we have to specify the index that we want to get. We're writing the name of the list, we're calling the method, and we have to specify what item do you want to get. Well, the item at index 0. Then we want to get the item at index 1, and so on. We're going to go from 0 up to 3, like this. And we're also going to print like a small separator so we can differentiate the output from the first sequence of print statements and the second sequence of print statements. We save the file and we run the code, and now we see the output, A, B, C, D, from these 4 print statements when we use regular indexing. And you can see that this is the same output that we get right here below. A, B, C, and D from these 4 lines of code, where we call the getitem method passing their corresponding index. So this is actually happening behind the scenes. Awesome, right? Let's see that this works correctly for strings as well, for any type of sequence that you can index. For example, let's say that we have the string word. It has 4 characters, so we can use indices from 0 up to 3. And we will need to rename this variable. We can change this manually, or we can just right-click on the name and click refactor and rename. That will prompt us to choose a new name. So we are going to name this my string, and we want to refactor. Okay? And that will change the name of the variable everywhere it occurs in our code. Now if we save the file and we run the code, we see the output. We see that the output from these 4 statements, these 4 print statements that we have right here, is the same output that we get if we call the getitem method behind the scenes, like this, okay, word. Awesome, so now you know how this works with built-in data types and data structures. So let's start diving into an example where we will customize this method in a class. In this example, we are going to implement a bookshelf class. We are going to start by defining the class header. And after the name of the class header, we have to define the constructor. Initially, the bookshelf, when we create that instance, will be empty. So we are going to define this. The content of the bookshelf is going to be determined or represented by a 2-dimensional list. A list that contains lists. Each one of those nested lists will represent a particular shelf or level in the bookshelf. Right here, I am assigning the name content to this attribute, but you could customize this and assign any name you like. You can see that this is starting to look like a bookshelf, so we're going to use this data structure in our code. After that, we have to implement 2 important methods. We're going to add a book to the bookshelf, and we're going to take a book from the bookshelf. To add a book, we need to know which book we are going to add and the location of the book in the bookshelf. Okay, so we're going to call this location. You could also customize this name. What are we going to do with the book? We're going to take the list of books in the bookshelf, the data structure that represents the structure of the bookshelf, and we are going to first get the location of the book, the level where it is located, where it will be inserted. If it's 0, it will be at the top of the bookshelf, the first list. If it's 1, it will be in the second level, and if it's 2, it will be on the third level. So we get that list, we get the level, and we append the book to that particular shelf in the bookshelf. That is what we are doing right here. We're taking the full structure of the bookshelf, we're getting its corresponding level or location, then we append the book. For simplicity purposes, in this example, the book will be represented with a string. It could also be a custom object with its own attributes, okay? Now we can add a book. And we also need to implement another method to take a book from the bookshelf, take book. We need to know which book we are going to take and where it is located, okay? In this case, we are going to simplify things by making the user specify the location of the book in the bookshelf. So let's see this. We're going to take the content of the bookshelf, its location as well, so we're going to get the list that corresponds to that particular level where the book is located, and then we are going to remove the book. In this case, we're going to assume that the book is already part of the bookshelf in the level that was specified by the user. You could also try to implement a conditional right here to check if the book is in the location that was specified. Great, so now we can add a book and we can take a book. So we have to start implementing the special method getitem. In PyCharm, you can see that we already have two parameters by default, self and item. We're going to customize this name to location because we are going to specify the location of the book as the index. If we pass the number 0, we will get the top shelf. If we pass the number 1, we will get the second level, and if we pass number 3, we will get the bottom shelf or the third level in the bookshelf. The getitem method is going to return all the books that are at a specific level, okay? Right here, we're specifying the location that is going to serve as an index. When we index a bookshelf instance and we pass, for example, 0, we will get all the books at the top of the bookshelf at level 0. Then, in the second level, we would get that level if we pass 1 as the location, and 2, we would get the third level, okay? So what are we going to return? We are going to return the content of the particular location or level that we want to get. We could also replace location with level or with any other description or shelf as well. Great, so we have our class. And what are we going to do with this? We're going to create an instance, my bookshelf. And it's going to be a bookshelf instance. We can create the instance without passing any arguments because we don't define any parameters right here. It will be an empty bookshelf initially. And after that, we have to start adding some books. We're going to add these books to level 0, to the top level of the bookshelf. Pride and Prejudice and Frankenstein. These 3 books will be at level 0, at the top of the bookshelf, right here. Then, let's add some books to level 1, to the second level in Sensibility 1. Sense and Sensibility, we're going to add the book Jane Eyre to level 1 as well, and then The Little Prince, level 1. Finally, we're going to add the book Moby Dick to level 2, the bottom level of the bookshelf, and we're going to add the Adventures of Huckleberry Finn to level 2, and the book Dracula. Awesome, so we've populated our bookshelf with our favorite books. And how are we going to test the getitem method? Well, we have to try to index the bookshelf instance that we just created. This instance, my bookshelf. We are going to print my bookshelf at level 0. What books do we have at level 0 of the bookshelf? Well, let's see. If we run the code, we see these books right here. We're using the syntax that we used to index a list, a tuple, or a string, but now we are using it with our custom instance, and we are passing the value 0 as the index. So we're going to get the first level in the bookshelf right here. Right here at the top of the bookshelf, we have these books. If we confirm this with our code, we see that it is correct. Awesome, let's change this to 1. Right here we see Sense and Sensibility, Jane Eyre, and The Little Prince. And that is exactly what we added to the bookshelf, Sense and Sensibility, Jane Eyre, and The Little Prince. And finally, if we change this to the value 2, we see this, Moby Dick, The Adventures of Huckleberry Finn, and Dracula. And that is exactly what we added to the bookshelf. Awesome, so now you know how to implement the getitem method in your class to be able to index your instances of the class. You can customize this to your liking. The parameter that you take right here doesn't necessarily have to be a number, and it doesn't necessarily have to be 0 to start the indexing right here. It could be 1, and by subtracting 1, we would get the same behavior. So the user would enter 1 to get the first level, 2 to get the second level, and 3 to get the third level. And that would be handled behind the scenes, indexing that starts from 0. Awesome! Now you know how to implement this method. When you're ready, go to the next video so you can continue learning more about special methods in Python and how to implement them. Now let's talk about the special method bool. This method is really cool because it will help us determine and customize when an object is true or false, so we can use them in a Boolean context. Let's see what we can learn about this special method in the Python documentation. If we go to the data model article in the documentation, we can then click right here on Basic Customization. After we reach the part of the article, we just have to scroll down a little bit and we will find the part of the documentation that covers this method right here, bool. You can see that it only has one parameter, self. Let's see what it says. This method is called to implement truth value testing and the built-in operation bool. It should return false or true. When this method is not defined, length is called. If it is defined, and the object is considered true if the result is non-zero. If a class defines neither one of these methods, all instances are considered true. We will see an example of each one of these scenarios. So, based on what we just read in the documentation, whenever we call the bool function, we are actually calling the bool method indirectly. This method will also be called if we use the object in a Boolean context, for example, in a conditional or as part of a condition. So let's start writing the code for our first example. We will be writing a bank account class. I'm in my PyCharm project Python OOP in the main file, and we will start defining our bank account class, bank account. Now, the first thing that we have to define is the class constructor. We have self as a parameter by default, and we also want to define the account owner, the account number, and the initial balance. Those are the three attributes that we are going to assign to each bank account object. Okay, so now we have our attributes and we are going to define two methods. Make deposit. For example, we have to specify the amount that we want to deposit to the account. What are we going to do when we make the deposit? We are going to increment the balance of the account by that specific amount. You might want to implement a conditional for this method and check if the amount is actually positive. Now we're going to implement a method make withdrawal. Okay? We're going to withdraw money from the account, but we have to specify how much. That is why we define a second parameter right here, amount. In this case, we do have to use a conditional. We have to write a conditional in the body of the method because we want to check if the withdrawal will be allowed. If the user or the account owner has enough funds in the account to make that withdrawal. If the current balance minus the amount that we want to withdraw is still greater than or equal to 0, then we can make the withdrawal. We are decrementing the balance of the account by that specific amount. If that is not the case, then insufficient funds will be the message displayed to the user. If we leave the class like this, without defining the bool method and without defining the length method, then the objects that we create from the class will always be true by default. They will never be false. If we use them in a Boolean context, they will always evaluate to true. Let's see this in action to confirm that they will always be true no matter what. Okay, so after we have these two essential methods in our bank account class, we can create an instance. Right now, we are not going to define the bool method, so you can see what happens if we don't define this method in our class. We say my account equals bank account, and the owner will be NorNF We're going to simplify this by just passing a string with the name of the account owner. This could also be a custom object. The account number is, for example, this is just a number that I made up. You can assign any number to this. And after that, we want to print the truth value of the account. We have our instance, okay? Now we have our instance, we have our class, and we want to actually print the truth value of the account. We can do that with the bool function. We can check if the account is true or false by calling this function and then printing the result. Let's save the file and run the code. We see that the account is true. Okay? We didn't define the bool method anywhere in our class, but by default, the instance will be true. So if we try to use this instance, for example, in a conditional, like a truthy or falsy value, let's see what happens. If my account, just like we use, for example, lists or strings to check if they are empty or not, right now we are using the instance directly. If we run the file, we see true, because the account was true by default. It will always be true, because we haven't implemented that method yet. And let's see what happens if I update the balance of the account to 0. If I print the new balance of the account, and I test again if the account is true or false, let's run the code. We see that the current balance is 0 and that the account is still true. So by default, all instances will always be true unless we customize or implement the bool method in our class. So let's start doing that. Now think about how you would implement this bool method in the bank account class. We want the bank account to be true if the balance in the account is greater than 0. And we want the bank account to be false if the account is empty, if its balance is 0. Pause the video for a moment and then come back so we can start writing the code. Right here we have the same class that we have been working with, and now we are going to add the special method bool. We're going to implement it in our class. This method only takes self as a parameter, and it has to return either true or false. But what is the criteria that we want to set to define if a bank account is true or false in our program? Well, we want to make the account evaluate to true if the account has a positive balance, if the current balance is greater than 0. If it is equal to 0, then we want the account to be false. So that is the criteria that we have to implement right here in our method. How can we do that? We are just going to return the truth value that results from making this comparison. Self.balance, we take the current balance and we check if it's greater than 0. If it's greater than 0, then this will be true. If it's not greater than 0, then it will be false. And that will be the value returned by the bool method. So now our bank account class, our instances, will be either true or false. Awesome, so now let's test this. We're going to add 2 print statements right here before we update the balance to 0. Before we update the balance, it is initially positive. So right now, we're going to print the balance to check that it is positive, and then we are going to print the truth value of the instance with the bool function. After that, we are going to update the balance to 0, and we are going to test this again. Let's save the file and run the code. We see exactly what we expected as the output. Right here, we have the initial balance, which is positive, and we see that the instance was true, evaluated to true right here. After we update the balance is 0 on this line, and right here we see that it is now false. This is something that we didn't have before we implemented the method. The instance was always true. But now, since we implemented this criteria, that the balance has to be greater than 0 for the instance to be true, we also have some scenarios where the instance will be false. Okay? If we use the account, for example the instance, as part of a conditional now, we will see print true, else, print false. We can use it. Let's write this right here, and let's write this after we update the balance. We'll be using it directly in the conditional. Let's close this so we can see this better. We have the two conditionals, and right here we update the balance. Let's run the code, and we see that previously it was true, and after we update the balance, it is false. Awesome, now you know how to implement the bool method. Let's see a final case that was mentioned in the documentation. Now we know what happens when we implement the bool method in the class, but there is another scenario that we could have that Python handles correctly. If we don't define the bool method in the class, but we do define the length method, like in a sequence, for example, that has a length, then when we call the bool function or when we use the object in a Boolean context, the value, true or false, will be determined by the value returned by the length function. So length sort of works as a backup. If we don't have bool, then the value of length will determine if the value is true or false. The program will ask, is the result or the value returned by the length method different from 0? If it is, then the object will evaluate to true. If the value is equal to 0, so the answer is no, the object will be false. This is just like when we use empty list or non-empty list. An empty list is false, like in this case, and a non-empty list is true. If the length is different from 0, it's true. If the length is equal to 0, then it is false. We're going to demonstrate this with a list. We say 1, 2, 3, 4, and 5, okay? If the list is not empty, we will get a particular message. Let's say the list is not empty, because it will be true. We're going to print this, and then we are going to print the truth value of the list, okay? But if that is not the case, then we are going to say the list is empty, and we are going to print the truth value of the list. Great. So let's save the file and run the code. Right now we see that the list is not empty, and we see the value true right here. This part of the conditional was executed because the list evaluated to true. Right here. Now, if we remove these elements from the list and we run the code again, now we see that the list is empty right here, and now it evaluates to false. So this is an example where the length of an object determines if the object is true or false. For example, let's write the string hello world. Strings are also considered sort of like sequences for the characters. So let's say my string, we're going to replace it right here. And we are going to say the string is not empty, the string is empty. We close this, we save the file, and we run the code. And we see the same output, the same behavior. The string is not empty, right here, so it evaluates to true. And this part of the conditional is executed. Now, if the string is empty, things will change because the string is now empty, and now it evaluates to false. So the else clause is executed because this evaluated to false. Awesome! So now you know how the length can also affect the truth value of an object. You learned in a previous video how you can customize the length special method. So now you know that that result can also determine if an instance is true or false. Great work so far during the course. Now we're going to cover rich comparison methods. Their main purpose is to help us compare objects based on specific criteria that we are going to define in our class. Because, for example, comparing two bank accounts is not the same as comparing two coordinates or comparing two dictionaries. The criteria has to be different, and that is why these methods are super helpful. These are the 6 rich comparison methods that we can implement in our class, and the corresponding comparison operator. When we use these operators in our Python program, we will be calling these methods behind the scenes, okay? Less than or equal to, not equal to, greater than, and greater than or equal to. Let's see some code examples of built-in types and how we use these operators with those built-in data types. And after that, we will customize these methods in our class. Let's see some examples of how we typically use comparison operators with built-in data types and data structures. First, let's test this with integers. For example, we can compare if 15 is less than or equal to 8. We can also check if 4 is greater than 4. We can also check if 5 is equal to 5. And finally, if 6 is different from 8, it's not equal to 8. In this case, we are performing these operations on integers, so they will be compared based on their value. If we run this, we see that the comparison returns a Boolean value, false or true. So we know that when we try to implement these special methods in our classes, we have to return a Boolean value, true or false. Now, the behavior of these comparison operators is different based on the data type of the values or the operands. For example, right here we were comparing integers, but we could also compare strings. And the criteria that is used to compare if a string is less than another one is completely different from the criteria that we use to compare integers, for example. Right here, we are going to verify if this string comes before this string in alphabetical order. It does because H comes before W in the alphabet. So that is a totally different criteria from our previous comparisons that we made right here. This is another example of operator overloading. We are using the same operator, but the behavior is different. The result is still a Boolean value, but the comparison is made based on different criteria, and that is the criteria that we will define. Right here we have other examples. Let's save the file and run the code, and right now we see that these three comparisons are true. We can also compare built-in data structures. For example, lists. We have 1, 2, 3, 4, and we want to check if that list is less than 1, 2, 3, and 5. In this example, we are using the same comparison operator, but the criteria is also different because we are going to be comparing each one of the corresponding elements in the list. For example, in this case, all of these values or elements are equal, but this value is less than this value, and they are in their corresponding positions at the end of each list in the same index. Since this comparison is true, then this comparison will be true. If we run the code, we can see that the last comparison right here is true. Let me comment this out so we can just see the result of this comparison as the output. We see true right here. That is the important takeaway from these examples, that the operators can be customized to work with different data types. Here we have another example where we compare the lists. Like this, we see true and true. So let's start working on our custom class. Think about how you would implement a circle class with rich comparison methods. We will have circles with a radius and a color. How can you determine if a circle is less than another circle, or equal to another circle, or greater than or equal to another circle? That is what we are going to define in our circle class. So take a moment to think about this, pause the video for a moment, and then come back so we can start working on the code. In this case, we'll be writing a circle class. So let's start with the class header, class circle. We will define the constructor with two additional attributes to self. We have the radius and the color. And we're going to be able to compare circles based on these two values or attributes. Okay, we have the radius and we have the color. How are we going to implement the rich comparison methods? Well, first, we can start with the less than method. You can see that these methods take two parameters, self and other. Self is the left operand. So if we have, for example, object 1 and less than object 2, this would be self and this would be other. Similar to when we implemented the add special method. We had a left operand and a right operand. The left operand is self and the right operand is other. Okay, so how are we going to implement this? We have to return a Boolean value, true or false. And what criteria will we use to determine if a circle is considered less than another circle? Well, in this case, we might use, for example, the radius. We might say, if this circle's radius is less than the other circle radius, then that means that the comparison is true. We're going to compare them based on the value of the radius. And in this case, we might not even consider the color. We might just consider the radius to determine if the circle is less than another circle. Similarly, we have to implement the less than or equal method. In this case, we can also use a radius as a criteria, but we will change the comparison operator right here, because we are comparing if a circle is less than or equal to another circle. And in that case, the radiuses can be equal. So that is why we use this comparison. If the radiuses are equal, then this will return true. And that is what we need. Now let's go to greater than, like this. And we are also going to compare them based on the radius using the greater than operator. Similarly, with greater than or equal to, we can see it right here. And we're going to compare the radius. We use greater than or equal to as the operator. And right here, we have to implement the equal to operation with this special method. How do we want to determine if a circle is equal to another circle or not? Well, we can use, in this case, both the radius and the color of the circle to determine if they are equal. If the radiuses are equal and they have the same color, then we can consider them equal in terms of their attributes. So in this case, we might want to write a condition like this. If the radiuses are equal, if self.radius is equal to other.radius, and the color of this circle is equal to the color of the other circle, then the circles are equal, and we return true like this. Let's reformat the file to follow the guidelines of the Python style guide like this. So we have this condition right here. We are comparing the radiuses and we are comparing the color. If both of those conditions are true, then the circles are equal. And similarly, we can implement the not equal to special method like this. We just use the same condition, we compare the radius, and now we're going to check if they are not equal. And there is a small change. Instead of using and, we are going to use or. Because if either one of the conditions is not true, then the circles are not equal. If they do not have the same color, then they are not equal. And if they do not have the same radius, they are not equal. So either one of those conditions can prove that the circles are not equal. Let's create some circle instances. We have our class with the rich comparison methods already implemented. So let's start creating some instances. We have circle A, and we are going to create a circle with a radius of 5 and the color blue. We're going to describe the color with a string. We're going to add a line right here, and we're going to create another instance, for example with radius 5, but this circle will be green. Now circle C will be a circle with radius 7 and color red. And finally, circle D is our fourth instance, and we will have it right here with a radius of 5 and color blue. So we can test our comparison methods. What are we going to do with these instances? Well, let's see if circle A is less than circle B. We can make this comparison because we have the less than a special method implemented like this. This is going to compare the circles based on the value of the radius, only the radius. In this case, the radius of circle A is 5 and the radius of circle B is 5. So we should get the value false. Circle A is not less than circle B. So we see exactly that. False. Awesome. Now let's test what happens if now we write less than or equal to. This also returns true if the circles have the same radius. So now we see true. Circle A is less than or equal to circle B. In this case, we're just comparing the radiuses. We could also check if their colors are equal. To verify that this is true, we could alter or change the implementation of this method less than or equal to also test if the colors are equal, like this. And self.color equal to other.color. And the same with greater than or equal to, because now we have to consider what happens if the circles are equal to each other. So if the radius of one of the circles is less than or equal to the radius of the other circle, of the right circle, and their colors are equal, then this comparison will be true. And the same with greater than or equal to. We're comparing the radiuses and the colors have to be equal. Okay? Now, if we make this comparison, instead of true, we will see the value false, because circle A and circle B do not have the same color. Now we are comparing them based on the radius and their color. So that is how you can sort of customize what happens when you compare your instances. Circle A and circle D have the same radius and they have the same color. So let's see. In this case, circle A is not greater than circle D, but it is greater than or equal to, so we see true, because they have the same radius and they have the same color. We can also compare if a circle is equal to another circle, for example, circle A and circle B. They have the same radius, but they do not have the same color. In this case, that is false. And if we compare it to circle D, we will also see the value true, because they have the same radius and they have the same color. If we compare them using the not equal to operator, we also get a Boolean value false. They are equal, so this comparison is false. Great, so now you know how to implement your class with customized rich comparison methods. This way you can compare objects based on different criteria, appropriate for the context of your object. In this case, we have circles with radius and color.